The relationship between the derivation sheet and the two diagrams is one of foundation and application. The derivation sheet acts as the raw ingredients or the theoretical source code, while the diagrams serve as structural maps that explain how those mathematical results are used to solve real-world problems and create visual simulations. The sequence diagram. Mapping the workflow. The sequence diagram illustrates the logical flow that begins with the specific steps outlined in the derivation sheet. From theory to engine, the diagram shows that the first step involves taking the abstract definitions from the derivation sheet, such as how the coordinate lines are related and how the scale factors are calculated, and feeding them into a computational engine. The secret sauce. It identifies the derivation's proof of orthogonality, that the coordinate lines always meet at 90-degree angles, as the critical point that simplifies every subsequent step. Physics integration. The diagram bridges the gap between the paper and pencil math of the derivation sheet and the domain-specific results found in quantum mechanics, electromagnetics, and potential theory. The state diagram. Branching into applications. The state diagram focuses on how the foundational core of the derivation sheet enables different physical scenarios. The starting point. It places the grid construction, the very first task in the derivation sheet, as the primary state. Proving that the T and S lines are orthogonal is what makes the subsequent examples solvable. Specific features for specific problems. The diagram explains that the derivation sheet provides three distinct mathematical tools used by different fields. Variable separation, used to transition from a theoretical quantum problem to calculating energy changes in an atom. Focal geometry, used to transition from basic parabolic shapes to demonstrating how satellite dishes concentrate signals. Boundary alignment, used to show how coordinate lines wrap around a sharp edge, allowing for the study of intense fields at corners. In essence, the derivation sheet provides the mathematical proof, the what and why. The sequence diagram outlines the process of using that math, the how, and the state diagram categorizes the results of that math across different scientific disciplines, the where.